We are not at the end of the chapter. We're getting closer. Not at the end. We're just slowly getting closer. Surface area of spheres. So we're to our last solid shape for this chapter. And somewhere I hope you have some notes where you have been taking these formulas down and hopefully memorizing them each day so that you don't have to memorize them all the day before the test or the night before the test or the morning of the test or other bad habits that we don't have. So our last solid here, we're going to look at surface area and volume of spheres. First of all, some definitions that go with spheres which are identical to circles. We have some of the same things. We have a radius in a sphere. We have a diameter in a sphere. We have chords. Remember, chords just intersect 2 points on the sphere in this case instead of circles. We have tangents where it just touches the sphere at 1 point. So all those definitions that came from circles, they are all the same thing for spheres. So how do I get the surface area of a sphere? We'll develop an idea of why it is 4 pi r squared. Tell me about pi r squared. What does that give us, just that part of the formula? That's a circle. That's the area of a circle. So maybe it's interesting to you like it is to me. If I have a sphere, its surface area is exactly 4 times the surface area of a circle with the same radius. So it's not some fraction, it's just exactly 4 times. So if you think of this circle and this sphere, this circle here is 1/4 the area of this sphere if we covered it. So 4 pi r squared. Whatever you can do to help you remember that little formula right out there. So let's see here. Surface area of spheres. 4 times pi times the radius squared. You would run your calculators quickly. 7.1 is our radius, so that we don't waste your work time getting these numbers. It's just simply filling in the formula. What do you get? Nearest 10. How much? 633.5 millimeters squared. Thank you. There's our area. This one right over here, we know that the surface area is 4 pi r squared, 4 times pi times what squared? 11. You got it. 11 squared is 121. 121 times 4, what's that? 484 pi. Whatever that is. Well,
Okay, times pi is
1,520.5 feet squared. Easy. Somebody asked me, was this lesson easy? I think the answer is yes. Easy. 4 pi r squared. Now, if I have a sphere and I take a plane and I intersect that sphere with the plane, there are 3 potentially different ways I can intersect it. One way is tangentially, where it, what does that mean? Just hits at 1 point. So that's what they're showing us right down here. We intersect just at 1 point. Or if I take that plane and I cut through the circle anywhere, cut through the sphere anywhere, the shape of the intersection is I said the word, is a circle. So right down here you can see that would be the circle where that plane is intersecting. If you take the plane and intersect through the center of the sphere, what do they say this circle is called? It's called a great circle. A great circle goes through the center of the sphere. And when it goes through the center of the sphere, it also goes through, think of the Earth. What do we call the top and the bottom of the Earth? Poles. North Pole, South Pole. The poles. Well, the poles of any sphere are really just the endpoints when you take a plane and go through the center of it. So there are poles here. You could have poles on the other side, or pole. You really could have 2 poles anywhere. They'd be the ends of any diameter. Question?
So I'm assuming that they took poles from magnets, or that magnets took poles from spheres. So which one came first?
There you go. My understanding is the magnets got it from the Earth. the poles of the Earth. So the sphere came first. Hemisphere. What is that? Cut it in half. When we have a great circle, right here is a great circle. We have taken a sphere and we have cut it in half. So that is a great circle, and this is a hemisphere. So I wonder what the surface area of a hemisphere would be. I want you to think just a minute. Can you tell me the formula for the surface area of a hemisphere?
1 divided by 2.
2 pi r squared. Now what you have just told me is this, 2 pi r squared, because we know this is 4 pi r squared. And what would be the area of the base? Pi r squared. So what would 2 pi r squared plus pi r squared be? 3 pi r squared. That would be the surface area of this right here. It is 3 pi r squared. Now they didn't put it up here, but that might be something you want to tuck into your memory, because it's kind of a convenient thing. Oh, find the surface area of this hemisphere. Well, I wonder what it would be. 3 pi r squared. And I hope you know where we got that. Where did the 3 come from? The base and half of that sphere, which was the 2, and the 1 make 3. So 3 times pi times, what's our radius? 2.8, which is square. What do you get? Here's 10. 7, say that again. 73.9 centimeters squared. Find the surface area of a sphere if the circumference of a great circle is 5 pi meters. So we know if we are going to find the surface area, we need to know pi, 4, pi, radius, squared. We need to know the radius. So how can I use the circumference to help me get the radius? Josh B. Okay, question.
Like, if I just seen that and it's a great circle, I would have thought that if they had cut it in half. So when they say hemisphere is half, but great circle is just...
Great circle just happens to be a great circle on a hemisphere. Doesn't mean we've cut it, but it is on the hemisphere. Anybody? How can I get circumference?
You can... Circumference is diameter times pi.
Diameter times pi. Now, you're right that, before we put any numbers, you're right that diameter times pi. I'm interested in the radius because I need to know the radius. Can you tell me a different form of this?
2 pi r.
2 pi r. Circumference equals 2 pi r. So since I know my circumference, now I'm going to substitute. It's 5 pi. 5 pi must equal 2 pi times the radius. How would I solve for the radius? How would I get this by itself? 5 by 2 pi. So if you divide by 2 pi, what happens to the pi's? What's 5 over 2? 2.5, or 5 over 2, whichever way you want to call it. 4 times pi times, I guess I'll call it 2.5. That has to be squared. What do you get to the nearest 10? How much? 78.5? 78.5 meters squared. So we use the information they gave us, the formula that comes from that information, to find our missing part. We do that quite often. See if we can take that idea down here. Find the surface area of a sphere if the area of a great circle is approximately 130. So here they've given us this area. Well, once again, I want surface area of a sphere. Surface area is 4 times pi times radius squared. What's the one thing I need to know to answer the question surface area?
You just know the base.
Radius. I need to know the radius. That's the one thing I need to know. So what am I going to use to get the radius?
Question. Can you just multiply that number by 4 technically, since that's the area of the base?
Oh, could I do that? Good question. What do you think? Could I just multiply that by 4? They told me the area of this great circle. Could I just multiply it by 4? I think so too. Look at the formula. That's the area of the great circle that we just discussed. So very good thinking that way. Now I'm going to do it 2 ways, but you're exactly right. 130. What's 4 times 130?
520.
520 inches squared. What's the area formula for a circle? Pi r squared. Let's see how well this works. The area they said was 130. Equals pi times radius squared. I'm trying to solve for that radius. How would I do that? Divide by pi. 130 divided by pi. That'll take care of that. And then what would I do? Square root. I want you to do that in 3 places. Question. This word right here. We're finding areas of things, surface area. When do we cube? Anybody? When do we have cube units? When we're talking about volumes. Cube units. Anybody have this number 3 places? 6.483? 6.433. Did I hear it right now? So try that back up here. Take 4 times pi times 6 point, and actually leave that number in your calculator. And square it. And multiply it times 4 and pi. What do you get? When you round to the nearest integer, do you get 520? Good. Good thinking. When you said, hey, wait a minute, I know the surface area formula. It's just 4 times the area of that great circle, and they told me the area of the great circle. Now let's look at the volume. So we covered the surface area. Let's look at the volume, and we're going to use a thought process to try to understand how we get this formula. So what they have done is they have taken a sphere and they've cut it into little pyramids. Now let me ask you this question. These little pyramids, this is the base of the pyramid. The base of the pyramid, is it flat? No, it's not. It has a curve to it, right? So when you first think of this, and they say, well, I can take the area of this pyramid and just multiply it by the number of pyramids that I might happen to have. And I know that these pyramids are 1/3 area of the base times the height of the pyramid. And the height of the pyramid going in would be the radius. So that's why they said R right over there. But you're saying that's not quite exactly right, because the base is curved. Here's where the thought experiment part comes in. I want you to make that smaller. So make that base smaller than it was in your mind. And then make it smaller. And then make it smaller. We're going to limit that base to, we're going to limit it to 0, we call. We're not going to go to 0. But we're going to get it really, 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 really close to 0 in size. As you get smaller and smaller pyramids, what happens to the curve of that base? It starts flattening out, doesn't it? It gets flatter and flatter and flatter, and it limits to perfectly flat when you limit to 0. So it actually works mathematically, even though we haven't really talked a lot. When you get into calculus, you learn more about limits. But you can kind of get an idea that when I make these bases smaller and smaller and smaller, they do get flatter and flatter and flatter. So all they have done is the area of a pyramid, 1/3 area of the base times the height of it, which is the radius. And we just need to add them all up. Well, I don't know how many we have, but I do know this. If I add up all the bases, if you add up all the bases, that would also be called the what of that sphere, if you added up all the bases. The surface area of that sphere, right? And we know a formula for the surface area of the sphere. What was it? 4 pi r squared. So we're just going to replace the sum of all the bases, which is just the surface area, with 4 pi r squared. So 1/3 the radius times 4 pi r squared. Well, what's radius times radius squared equal? Radius cubed. And what's 1/3 times 4 equal? 4/3 pi r cubed. there is an understanding of how we can get that formula. Now you can also take the derivative of the surface area of the sphere when you get to calculus, and that will also give you the volume formula. So there's more than one way, but this is a geometric understanding of, I can see how this would make sense. Volume of a sphere, 4/3 pi r cubed. So I wonder how we're going to find the volume of this thing. It says a hemisphere, a radius of 6 meters. Can you adjust that formula for me? What do you think the formula for this volume would be? Well, what's different? This is half, right? This is half the volume. Divide by 2. Or, let's write it out. If we take the volume of a sphere, 4/3 pi r cubed. I'm just going to multiply it by 1/2. I want half of this. Well, what's half of 4/3? 2/3. Just reducing there, 2/3. So the volume of this hemisphere is 2/3 pi r cubed. What's half of 4/3? 2/3. That's all we're doing. 2/3 pi r cubed. So 2/3 times pi. They gave us the radius of 6. We have to cube that. What do you get? Nearest 10. Let me get this number, then I'll answer that question. How much? 432.4? 452.4? You have to speak up so I can hear over the air conditioner, so I know you can hear yourself. Thank you. 452.4 meters cubed. Why is it meters cubed this time? We've got a volume going on. Did you get your own question answered by why we were taking 1/2? All right, we got that figured out. A sphere with a great circle circumference of 18 pi. We're supposed to find the volume of the sphere. Well, we know the volume of the sphere is 4/3 pi r cubed. So what do we need to get or know to answer that volume question? The radius. Can I just throw in the 18 pi anywhere? That was so convenient last time. No, it's a circumference, so that's not going to help us. But what is that circumference formula that will help us? 2 pi r. Circumference is 2 pi r. Not going to rearrange it. The radius equals, if I was solving for the radius, what would that equal? C over 2 pi. And we know our circumference is 18 pi. What's 18 pi divided by 2 pi? 9. Pi's gone, 18 over 2 is 9. 9 is the radius. 4/3 times pi times 9 cubed. Nearest 10. $3,000, how much? 53.6 centimeters cubed. Last example. Soccer ball globe at the right was constructed for the 2006 World Cup soccer tournament. It takes up 47,916 pi cubic feet of space. They just told us the what by telling us how much space it takes up. The volume. They just told us the volume. Assume that it's a sphere. Pretty close. What is the circumference of that globe? What formula gives us circumference? 2 pi r. What's the only thing we need to know? The radius. So we're going to go back to our volume formula, which is 4/3 pi r cubed, and we're going to fill in the things we know. We know the volume. 47,916 pi is the volume. That must equal 4/3 times pi times the radius cubed. And we're trying to figure out what the radius is right down here. You tell me some math steps I can begin to take. What can I do? I'm going to divide by pi, which I think I heard. Get rid of the pi. How will I get rid of the 4/3? And multiply by the reciprocal, which is 3/4. 3/4 times 47916. Now that equals the radius cubed. How do I get the radius?
Technically, the radius is r plus r squared.
Tell me this question. If you had 49 equals r squared, how would you get r? You would take the square root. You guys were quick and accurate in giving me what I would do. So what do I do if I want to get rid of r cubed? Cube root it's called. Take the cube root. Now how do I take the cube root? It has a little index of 3 in order to get rid of that thing. Some of you on yours, and you need to look at your calculator, some of you will have what's called an X root button, where you can fill it in with a 3. There's another way of doing this. Somewhere in your algebra memory, you should know that the square root of 40, let me just say x. The square root of x can also be written as x to the 1/2 power, which means the cube root of a value can also be written as x to the 1/3 power. So there's another way of doing it. You might have that button. You might even have a cube root button. Some of yours might even have a cube root button. Or you can also take 3/4 times 47916, change those to brackets, and raise it to the 1/3 exponent. However you can do it on your calculator, tell me an answer for r. You have 33? Exactly 33? Could be. Anybody else? I don't know what r is. 33? Let's go with 33. Now you're going to need to figure out how to do this, and I can help or your neighbor can help. Now we're going to go back and actually answer the question. That's the radius. So we wanted to know the circumference. 2 times pi times that radius. Now 66 pi is the exact. Approximately. And we can check and see if this answer is right. Any answer? 207? Point 3. Is that what you're getting?
Yes.
Correct answer. Let's go to our books. So you might have to take cube root sometimes. Page 884. Page 884, number 1. They want us to find the surface area of each sphere or hemisphere and round it to the nearest tenth. What's the formula again for the surface area of a sphere? 4 pi r squared. 4 pi r squared. So 4 times pi times, is that a 9? Squared. Nearest 10. Copy down the work too. I should not see just answers. $1,017.9 meters squared surface area. So how about this hemisphere? We're trying to get the surface area of this thing. What formula can we use? 3 pi r squared. We've got half of the 4, 2, plus another circle, pi r squared. 3 pi r squared. So 3 times pi times 7 is our radius, which has to be squared. $461.8. 461.8 inches squared. A sphere with an area of a great circle of 36 pi yards squared. So how can we get the surface area of that whole sphere? Multiply it by 4. 4 times pi r squared, or 4 times our area of that great circle. 144 pi, or 452.4 yards squared. A hemisphere happens to have a circumference of 26 centimeters. What do we do with that? What?
Oh, never mind. Sorry. Get radius.
We need to get the radius. We're going to have to go back to our volume formula of 4 pi r squared, and we need to know the radius. So circumference is found how? 2 pi r. So we did it a little bit ago. If I want the radius, I just take the circumference and divide it by 2 pi, and I'm writing down how we're getting it. Our circumference is 26, divided by 2 pi. Now I'm actually going to leave this as a fraction. How do you reduce 26 over 2 pi? 13 over pi. And I'm going to fill that into the formula for volume. 4 times pi times 13 over pi squared. Question. Is it a hemisphere? A hemisphere. So instead of that 4, what do I need to do? And did they ask for volume or surface area?
Surface area.
Surface area. What normally is the surface area of a hemisphere? 3 pi r squared. So I better change this to 3. Good thing somebody was paying attention there. Now you actually could do some reducing with the pi's. I'll do that as some of you are working. This pi takes care of 1, but that was squared, so there's still another one down there. 13 is squared, and there's still a pi. Does anybody have an answer yet?
161.4.
161.4 centimeters squared. So I guess the moral of the story is pay attention whether they say hemisphere or sphere, and make sure you're getting the surface area if they ask for the surface area. Number 5. Find the volume. So here we go. A sphere with radius 10 feet. What's the volume formula?
4/3 pi r cubed.
Pi r cubed. They told us the radius, didn't they?
10.
10. Here's 10.
$1,188.8.
Is it in feet? Number 6, they want the volume of a hemisphere, and they told us the diameter is 16 centimeters. What would the volume formula for a hemisphere be? 2/3 pi r cubed. So it will be 2/3 times pi. What's our radius?
8.
8 cubed. 10,072.3. 1,072.3 centimeters cubed. A hemisphere. We're supposed to find the volume of this hemisphere. It happens to have the circumference of a great circle of 24 pi. 24 pi centimeters. 24 pi meters. Well, we know it's a hemisphere, so we know the volume formula would be 2/3 pi r cubed, and we're going to have to do what? Find the radius. And we know the circumference is 2 pi r, so we know the radius is the circumference divided by 2 pi, and the circumference is 24 pi. What do you get when you take 24 pi and divide it by 2 pi? 12. Just get 12. So our volume must be 2/3 times pi times 12 cubed.
3,619.1 meters cubed.
3,619.1 meters cubed. So you can see what they're going to be doing in this homework assignment. They're going to be giving you different information. Find what you need to then be able to use your volume or surface area formulas. Number 8, they want us to figure out the volume again of a sphere. The area of a great circle is 55 pi. Inches square. Now, what's the volume formula again? And is it a sphere or hemisphere? Sphere. What is it?
4/3 pi r cubed.
4/3 pi r cubed. What can we do? Josh?
4/3 times the area times pi.
We could do that. Let's look at this formula a minute and separate it. 4/3 times pi r squared times r. Since r squared times r is r cubed, and what's pi r squared stand for?
Area of the center.
Area of that circle, that great circle, which happens to be what they told us. They told us that this area is 55 pi. So we could find the volume 4/3 times 55 pi. Now what?
We need 1/6. Are we radius?
We need the radius. So what you've said is true. We're going to end up having to figure out the radius anyway. How do I find an area of a great circle?
4 pi.
Pi r squared. It's just a circle. Pi r squared. So they told us 55 pi was the area of it, times pi r squared. Well, what about these pi's in this formula?
They cancel out.
They would cancel, and how would I get the radius?
Area of 55.
Square root of 55. Now I'm just going to leave it written that way. I can throw it over here, square root of 55, and you can do it that way. Or you could go back all the way to the original, 4/3 times pi times the radius, which is the square root of 55, and then cube that. Won't matter. If you do them right, they'll give you the same answer. 5,700, 1,708.6. 1,708.6 inches cubed. So Josh, you were right. Pi r squared we could separate out. We ended up still having to get the radius. Number 9. basketballs used in professional games must have a circumference of 29.5 inches. What is the surface area of the basketball? Well, we're assuming it's what shape?
Sphere.
A sphere. I hope it's a sphere. It would not bounce very well if it was not a sphere. So, surface area formula, what was that again?
4 pi r.
4 pi r squared. So once again, we're going to have to use the circumference to find the radius. Circumference is 2 pi r. So we know the radius is the circumference divided by 2 pi. 29.5 divided by 2 pi, and I'm actually just going to leave it that way. Surface area, 4 times pi times, and I'm going to use parentheses in my calculator when I go 29.5 divided by 2 pi. And I would recommend all of you trying this to make sure that you are really dividing by 2 pi and not just dividing by 2 and then multiplying by pi. See if you can all get the right answer. Because if you don't, that's a little warning sign that I'm messing up how I'm entering this.
26 or 26.
26,000.
Here's what the book claims it is. So I'm hearing one person at least saying that number. If you're not getting that number, now would be a good time to get help to get that number.